Welcome to this channel, and we're gonna discuss about sorting in data structure algorithms. Sorting algorithms. We have a lot of sorting algorithms. Today, yep, we should discuss what is sorting in general and how it can help us in any kind of cases, in any kind of scenarios. Why it's essential to learn sorting in data structure algorithms. So the introduction is sorting techniques. Uh, yeah, you can you can understand yourself that sorting is to make values sorted in ascending order, maybe descending order. So it will look good first of all for look. Then it will be easier to take out the value, the in kind of array or the set. You could just take off the value easily. So sorting will help us to do that. And we have, as I mentioned before, we have different sorting techniques. They vary in terms of logic difference and also in terms of time complexity and space complexity. What does it mean? If you know what time complexity and space complexity is, you will clearly know what it is. But if you don't worry. I'm gonna also explain this part while observing each sorting technique. But today we're gonna only observe bubble sort values. So first I'm gonna just again explain what is bubble sort, the main logic of the bubble sort, and then I will write with you pseudocode and the real code to understand. Bubble sort is everyone consider this sorting technique, sorting algorithm as the easiest one, and no surprise about this because the logic is that you swap values inside of the array until it's sorted. This you compare one to another, and if it's smaller, if it's higher, I mean, if it's bigger than this, you just swap. If it's not, it just stays the same and it goes to the next element. Mm, Time complexity. Time complexity in this case in bubble sort is big O n square. What is big O n square? So yeah, time complexity is the amount of time needed for each algorithm to execute to fully perform the time complexity. How much time it will take. And we are not measuring time, for example, in seconds. Yeah, I mean, you may not even notice because your ID or your PC or laptop is nowadays are like running anything on milliseconds. So it's not even, and also when you may think that 2 or 1 millisecond does not matter, but if you will have bigger values, if you will have massive projects, and their time and space complexity will matter the most, and they will follow, and they will use the best one, the best option. So here, but just at the beginning, we should observe each sorting technique, then choose the best for us because we're all different, and maybe for someone survival sorting algorithm will be relevant. So yeah, but nothing wrong observing each sorting technique because it's at the first at the same time interesting and at the same time beneficial for us. So yeah. Uh, in terms of space complexity, it takes O1. So it means the constant value. So let's move, first of all, Um, just as I said, we'll write the pseudocode. Uh, so let's imagine that we have array with values, unsorted array. And also we have, yeah, that's all. We have the array. So what we need to do? So as I said, it's just swapping until it's sorted. Here we compare, first we compared, I and j. So as you can see, j is I plus 1. So the next element that we are comparing. So it is the next element. Then, but I mean, if the number on the index at the index j is less than I, we're not comparing indexes is pointless. Uh, and I'm just writing because it's a pseudocode, but in the reality, in the real code, you writing and comparing indexes, it's pointless. But okay, I'm gonna do that. If and yeah, I forgot. We should declare a value for swapping. Swapping, yes. And here we just swap I and J. But swapping in the real code, we should need an extra variable to temporarily store the data and then switch up, switch up. This at first temporary storage has 0. The value of the temporary is 0. Then you could just put something there, take away something there just to switch up, you know. Yes. So that's the logic of bubble sorting. And this is the equivalent of, I'm gonna, yeah, write the code itself. Okay, okay. Now, s- so we have separate memory. Then, in order to like see the difference, I will run the loop. Oh no, no, no. Then before and then, that's why. Here, we need we need nested loop technique. We need nested loop logic. So we have inner loop and outer loop. I is 0, I is slang, I is plus plus. Checking each value, checking each value. Sorry for the 0. Then we have I plus 1. So yeah, num slang j plus plus. Then we're just comparing j if j is less than nums e temp. Yeah, we're switching here. Nums j. So at first we're storing nums j, the number number at j's index. Yes, and then we're first of all switching the values, and then we're declaring, yeah, just a swapping. This is the logic of bubble sorting. Let's run the code. If something is wrong, I'll see that it may be something wrong. But 1 4 9 11. Well, no, this is not 1 2 3 5 7 9. So yeah. Oh, I forgot to write this. I'm sorry. Yes. 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 So here, as you can see, before sorting, it is 2 5, like exactly like in the nums. Then after bubble sorting, it became sorted. Here, and then right now we need to, if we want to see how many steps it took to sort them, we need to, yeah, it's interesting. It's interesting to see how many steps it took. Plus plus, and here. So you can see that it took yeah 6 steps. The number of, no, it's not always the number of values here. It's not exactly like that, but this situation, this case, it took 6 steps to sort. It's the easiest one, and the logic is not that complicated, and that's why it's O and square, and it's the easiest one. Yeah. So yeah, it is this, as you have seen in the presentation. This is the time complexity of bubble sorting. If we put like 10, 23, 20, 13, and 19, so yeah, then we'll have steps of steps for sorting. 5, 7, 9, 10. Yes, it is sorted. It is 11, as you can see. 1, 2, 3. So it's 6. So it's 9. So it's 11. Yes. So today we have observed and learned. I hope so that we learned the bubble sorting, and in the next lesson we will. Okay, in the next lesson we will look for two sorting techniques. Thank you for watching this video and have a nice day.